Hi there, this is CUSD Math 7, Unit 5, the end of unit review, and I'm going to do some of the solutions here for this review packet. Most of them I'm going to do just the odd ones here for you, okay? And so a lot of the even ones are very similar to the odd ones, so you should be alright. If you get stuck on something, then just look back at an odd one and see what did we do there to make that work, and how can you apply this to the even question there as well. But hopefully this gets you started with your homework packet and get ready for the test coming up here, because we want you to do really well. Okay, use the number line to answer numbers 1 through 3. So we're going to use this number line for all three of these problems here. And we notice in the number line a couple things. We see that it's broken up. We have the numbers 0, 1, 2. We have a negative 2/5 as a point given to us here, and negative 1 and 2. We also see that's broken up into, looks like fifths, right? We have 1, 2, 3, 4, 5. So we can see that inside of all of these there are 5 parts, right? So this is what we call fifths. Okay, so the distance from here to here is 1/5 right there. If I had 2 of them, I'd have 2/5, and so on. Okay, so just keep that in mind. That's important for answering these questions. Number 1 says, what numbers are exactly 2/5 away from point P on the number line? So here's point P, and it does say, notice, numbers, which means there's probably going to be more than one, because we can go in either direction. So if I go 2/5, that means I'm going to go like 2 kind of hops is what I'm going to do. I'm going to go 1, 2 for the first one, and where do I end up at? I end up at 0. So 0 is 2/5 away from P. And let's go the other way. I go 2 hops, 1, 2, I end up right here. Well, what is this value right there? It's not 1, but it's going to be, if this was negative 2/5, we're going to keep counting, negative 3, negative 4/5. And that's where we are. So negative 4/5 right there. For number 2, it wants to know exactly which numbers are exactly 1 away. Now 1 away means we're using what? We're using the whole values, or you can think of 1 is the same as 5 out of 5 if you want to use the smaller values, or small little lines. Well, I'm going to look at number 3. What numbers are exactly 4/5 from point P? Okay, so same idea. We're going to hop 4 times. 1, 2, 3, 4 puts me right here for one of them. And this is going to be at above the 0, so positive 1/5, positive 2/5 right there is one solution. And moving this way, we're going to hop 4, 1, 2, 3, 4. And so we're going to be here. At this place, I'm at negative 1 and an additional 1/5. 1 and 1/5. All right, there you go. Number 4, we had a few of these on your homework packet throughout the unit, so you should be okay here. You're just deciding whether it's true or false. And really, they're just wanting to know, is this going to work out? You don't even have to do the math here. It just wants to know, if I do this, will it be negative? If I do this and this, will it be negative? This, positive. This and this, positive. This, positive. This, negative. So you don't have to solve it. All you're looking at really are the signs and the computation, what you have to do there to decide what if it's going to be positive or negative. That's it. So just decide which one it's going to be and mark your answer down. Okay, number 5. Number 5, we're going to do this together. 6 is exactly the same idea. So it says a hiker is 15 feet above sea level. So here's our hiker right there at 15 feet. And I put it on a number line for you. Okay. A diver is 20 feet below. And there's our diver, 20 feet below. So it's down at the negative. And it says find the difference in feet between the hiker and the diver. So the difference in feet is going to be taking our 15 of the hiker, and difference means to subtract, and we're going to subtract the distance the diver's at, which is negative 20 feet. That's his distance. And a negative, or subtracting a negative number, is the same as what? Adding. And 15 plus 20 is 35. And so the distance between here and here is 35 feet. And you can just count that out by 5s, right? We can go 5, 10, 15, 20, 25, 30, 35, and show that that is true. All right, that is the idea, and it's positive because it's just 35 feet. We're not worried about the negative because we're just measuring the difference there with that magnitude. Number 6 is the same idea, except you're talking about a bird up here and a whale down there, and again, find the difference. So I'll let you do number 6. All right, number 7. 7 says to select all values equal to 5. Notice that it is positive 5, and all values probably indicates there's more than one solution here. Okay, so we have negative 25 over 5. Well, 5 goes into 25 5 times, so I get 5 over 1. So that is a 5, but it's negative, so that's not going to work. 3 goes into 15 5 times. That's true. And a negative 5 divided by a negative 5 means it's going to be a positive. So we just have a positive 5 as an answer. That works. 25, 5 goes into 25 5 times, but I still have a negative out in front, so I still have a negative 5 there. And our last one here, so that'd be a no. 25 divided by 5, or 5 goes into 25 5 times. That works there, but a negative divided by negative is a positive, so we end up with positive 5. That's going to work. Okay. Number 8 is the same idea. You're looking for all values that equal negative 56. So work that out and make sure it equals negative 56. All right, I'll let you do that one. Calculate the value of each expression. So I'm going to do the odd ones here. All right, so first of all, we have a fraction. We have this. I have a negative times a negative. That's going to be a positive. And a positive times a positive is going to be a positive. So I should end up with a positive answer here if this all works out. So I'm just going to keep that in mind. Can I do anything about this 3 on the bottom, the denominator? Sure, because 3 goes into 18 6 times. 6 times 3 is 18, so I can reduce that, which eliminates the denominator. So let's rewrite this real quick. So now I have negative 6 times negative 2 times 4. And now I just move on through. Negative 6 times negative 2 is going to be what? Positive 12. And positive 12 times 4 is a positive 48. All right, number 11. Negative 9 times 3/4. Can I reduce with the 9 and the 4? I really can't. And this is here because you might think, oh, I'll reduce this way. Remember, you can only reduce on the diagonals, right? Or we can reduce vertically. We never, ever, ever reduce horizontally. Okay, so I can't reduce there. So I'm going to rewrite this here as negative 9 over 1. And I'm just going to multiply straight across. Negative 9 times 3 is negative 27 over 1 times 4 is 4, and I just leave it like that. That's all I can do with it. If you wanted to, or if your teacher wanted you to write that as a mixed number instead of an improper fraction, you could do that. We could recognize that 4 times 6 is 24, right? 4 times 6 is 24. So I know that there are 6 4s inside of there, okay? And then 27 minus 4 is 3, and it leaves me with 3 left over. So I could write it as a mixed number like that. Either one would work. Number 13. We have a negative 12 minus a negative 8 plus 2. So the key here is to rewrite this. So we have negative 12 plus 8 plus 2. Okay? So it doesn't matter which way I want to do this here. I can do it either way. I'm going to choose to say, let's put the 8 and 2 together, but let's go left to right. You probably were taught that way. So negative 12 plus 8, those are two different signs. So I'll find the difference. 12 minus 8 is 4, and I keep the larger sign, which is negative. And negative 4 plus 2, I find the difference because the signs are different. So 4 minus 2 is 2, and I keep the one with the larger sign, so it stays negative right there. All right. Number 15 and 16 here says, if a bank represents deposits of the money with positive numbers, deposits are positive, and withdrawals with negative numbers, explain what the expression represents. Okay, so here we have 28, which is probably our money, $28, and it's positive. So what we see happening here is happening 4 times. So we would say this probably represents 4 deposits of $28 in the bank account. Okay, and that's 4 groups of 28. They deposit $28 4 times. And again, we said that's a deposit because it's a positive number. All right, I'll let you do 16. All right, 17. Which of the following expressions are equivalent to that one? Equivalent means it's going to be equal to. All right, so they're going to have the same solution. So what I'm going to do here is I'm going to solve this one for you, so at least you're on the right track, and then let you figure out A, B, C, or D. Notice it does say again, select all that apply, so you might have more than one answer. So for this one, 3 minus a negative 8, we're going to add that up. 5. So 3 plus 5 is actually 8. And 8 minus 66, these signs are different. So we find the difference. 66 minus 8 is going to be what? It's going to be, borrow here, we have 58. But I keep the bigger sign. So I have negative 58 as my solution. I want to figure out which of these also is going to have a value or an equivalent solution of negative 58. So work those out and see what you come up with, but it should come up to negative 58. Just watch the signs and what you're doing. All right, I have some bank accounts here for 18, 19, and 20. Little tables, we've done these as well. So we're looking at transactions from a bank. And we talked before about a positive transaction is going to be money added to the account, but a negative is going to be money subtracted from account. Okay, so that's when it comes to transaction. When it comes to the balance is going to be positive, means you have money. A negative balance means you don't have money. You owe money. Not a good thing. All right, so looking at 18, you're going to see what happens here, and it wants you to explain what it's telling you. So you had 465, a transaction of that, and now you're there. So write in words what is happening here. I'm going to do 19 for you. Diego had negative 175. The transaction was negative 100. Now he has negative 275. So what are we seeing here? We would say Diego's starting balance was a negative $175. Okay. He had a withdrawal of $100, which means withdrawal is a negative. So he had no money, and he took out another $100, which he didn't have. So he had a withdrawal of $100. He now has a negative balance of $275. So what we're seeing with Diego is this. He had no money in his account. He took out another $100. So now his account is what we call overdrawn by $275. Right? It doesn't make a lot of sense. It's like now he owes the bank. He already owed the bank $175. He took out more money, so now he owes the bank $175 and $100 more to make it $275. So what we're looking for here is just to write down an explanation of what is taking place with this transaction for 18 and 19 as well. And you can see with Han, he starts by owing the bank some money, but ends up being okay and having some money back. And why is that happening? Well, the transaction. Notice the transaction here is what? It's positive. So write a little scenario about that one. Okay, on the next three, we have the transaction amount missing. So we have to kind of see how do you go from the old to the new. Notice with Jada that she kind of since owes the bank $25, and now she owes them $175, which means whatever the transaction is, it made it worse for her. She wasn't adding money in, she's taking more out. So what we can do is find out how do you go, and you can think about a number line here. Think about if this is your money and you're at 0, and first you're at negative 25, and now you're down here at negative 175, if that's her money, how much more money did she take out of the account to get to negative 175? So what's the difference between these two amounts is the idea. So I could do 175 minus 25, and I have 150. Okay, so the transaction is going to be what she took out. She took out an additional negative $150 is what she took out of that account. That's the space between these two numbers. Okay, I'm going to look at 23. All right, here's our number line. Look at something like this. So Han is sitting here at 350. And then the new balance is 515. So what transaction happened right here to make him go from a balance of 350 to 515? So when I look for that space between, that's going to be the difference still. 515 minus 350. 5 minus 0 is 5. Can't do that. 11 minus 5 is 6. 4 minus 3 is 1. So we're going to have a difference. The space between is 165. We're talking about increasing there, so we keep it just a positive 165. And sure enough, 350 plus 165 does equal 515. All right, next page. This is actually our last page here. It's amazing how fast it goes sometimes, huh? All right, 24 we're not doing, but you can look at 24 and what it shows you. Get that in the screen there. It says determine whether each expression has a positive or a negative value, and when you substitute these things in. So you're going to look at x equals -2, y equals -5. You're going to put them in place of x and y, and just decide, is it positive or negative? That's your thing. I would just solve them out to figure it out. I'll do the fraction one here with you, okay? So same idea for here, positive or negative. All right, and here x is -1/3 and y is -2/3. The number line is just showing you where they are, okay? So, which means it's just designed to help you. So if I had a -1/3, that's the x value, plus the y value is -2/3. The signs are the same, so I find the sum. 1 plus 2 is 3. The denominator stays the same. And because I'm finding the sum and the signs are the same, I keep the sign the same, so -3/3. And that's going to be equal to -1. And so we have a negative answer there, right? I'll just write it in for negative. For the next one, we have a -1/3, and we are subtracting a -2/3. So when I subtract, what am I going to do? I'm actually going to add. So -1/3 plus 2/3. Denominator stays the same. -1 plus 2. Well, that's like the difference. 2 minus 1 is 1. And which one is larger, a 2 or a 1? The 2 is, and it's positive, so it's going to stay a positive 1/3, and we would say that is a positive value there. The next one, we have a -1/3, which is x, times -2/3, which is y. And again, multiply that out. 1 times 2 is 2, 3 times 3 is 9. A negative times a negative is a positive, so that's going to be a positive solution. And D, which is an interesting one here, right? Because you're like, wait, I don't know. This is a great one. Don't get too stressed out, because what does this fraction bar also mean? This is like saying x divided by y. So I could write that like this if I wanted to. X divided by y, and then plug things in. So I could do a -1/3 divided by -2/3. And to solve that there, I could do -1/3 times reciprocal, -3/2. We could reduce, and -1 times -1 equals a positive 1. And then 1 times 2 is 2, and that is a positive value there. Now, again, it didn't ask you to solve them, so I did more work than needed. But what you should have seen here is this: we're doing a negative number divided by a negative number, and a negative by a negative is a positive. Same thing here. Negative times negative is positive. Okay? So those ones, you don't even need to calculate. It just wants you to decide positive, negative. Let's look at the last set of questions here. We're going to just solve these out. Okay? So to get the b by itself, I multiply by the reciprocal, both sides by the reciprocal. So 5/1. Reduce. So b equals -8 times 5 is -40, and I don't worry about the denominator. This next one here is a little interesting because I have this -y, and you don't want to have a negative variable, so that's why this is set up this way. It's a great little question for you, just to know, do you know what you're doing? Maybe think about it this way. Maybe just add the y to this side over there real quick. So now I have 12 equals 12.5 plus y. Is that okay to do? I sure can. I mean, as long as you do it to both sides, we're okay. Just don't combine the whole number with the y. They're separate. Now let's subtract 12.5 from this side. Okay, so y is going to be equal to the difference between negative 12.5 and 12. All right, so what's the difference between negative 12.5 and a positive 12? Okay, well, 12.5 minus 12.0 is going to be equal to 0.5. Now, which one has a larger absolute value? The negative does. So we're going to keep it negative, and we have negative 0.5 equals y. And finally, number 28, great question. We have a negative and a negative. We have a c. So we're going to divide both sides by 20. Okay, so let's rewrite this real quick. I'm going to rewrite this as a negative 2/10 equals negative 20c. I'm going to divide this side by negative 20, and I'm going to think about this as being divided by negative 20, or I could write it like this: negative 2/10 divided by negative 20 equals c, which I could rewrite as negative 2/10 times 1 over negative 20, right? Divided by 20 is like that, multiplied by the reciprocal. And so we can reduce, and we have a 1 there, and we have a 10 there. So we end up with a negative times a negative is a positive. 1 times 10 times 10 is 100, and we are okay right there. And again, you could do that with a calculator the same way, right? And if I use my calculator, I would have the 0.2, not worry about the negative for right now, although I guess I could do 0.2 negative divided by 20 negative, and we end up with 0.01. So if you have a decimal answer, that's because it's 0.01, which is what? It is 1/100th, or 0.01. Okay, just wanted to show you how that works with a regular fraction way. That's it. Did all the odd and some extra ones there. Hope that helps you out, and good luck on your coming tests, and let me know how you did. Have a great day.